Welcome to the second note-taking guide and this video segment on family of functions. You'll notice that this note-taking guide does not have a few paragraphs for you to read and to respond to. We're going to skip that this time. We've been working on that a lot. We're going to take a break from that on this note-taking guide. So in this video, we're going to learn how to add functions. And in the whole note-taking guide, we will be adding, subtracting, multiplying, and dividing functions. This takes a little bit of time simply because we have to go back and brush up on our factoring skills when we get to division. So let's look at addition and what that notation looks like. We're going to have two different ways this is written. We're either going to have f plus g of x or f of x plus g of x, and they mean exactly the same thing. We're just combining and adding those two functions. So our first step is just to replace the function names with their equivalent expressions. Easy enough to do. Then after that, we're going to eliminate the parentheses. From around those expressions. And lastly, we're going to combine like terms. Nothing new here. We were combining terms in our last unit in Algebra 1 review. Let's take a look at our first example. I have f plus g of x, where f of x equals 3x plus 8, and g of x equals 2x minus 12. Step 1 says just replace the function names with those equivalent expressions. Second step, simply remove the parentheses. Keeping all my signs exactly as written. My third step is just to combine my like terms. So I'm going to gather them first on this next line. I'm going to have 3x plus 2x, my two like terms. My next terms, or my next two terms, like terms, are constants, and I'm going to have 8 minus 12. What makes, just as a reminder, what makes a term a like term? It's when the variable and the exponent portions match exactly. So I'm going to combine 3x and 2x. 3 plus 2 is 5, so I have 5x plus, and 8 minus 12 is negative 4. This can really be written, you often won't see, or you won't often see, this plus minus. This will be written 5x minus 4 as the solution. So that is our first example. Just combine those like terms. And we will look at another one, and then we'll let you off and let you try a couple on your own. All right, our second example, f plus g of x, where f of x equals x cubed plus x squared plus 3x plus 7. I'm going to write those functions down without the function notation, just the expressions. And then g of x minus 3x cubed plus 7x squared plus 1. Next, step 2 said to remove the parentheses. Easy, I can do that. All right, now I have a huge line of terms. And one method that I would suggest you do, sometimes when I'm working on the board, I'll use different colors of pens to indicate what the like terms are. Another thing you could do is simply cross out the like terms as you gather them. So I'm going to start here. I've got my x cubed minus 3x cubed. And as I do that, I'm just going to cross those out to make sure that I gather all the terms. Next, I have x squared plus 7x squared. And once again, cross those out. I have 3x, no other simple x's in there, and then 7 plus 1. And if I look at this line, everything has been crossed out, so I know I've gathered all my terms. So now I just combine those like terms. X cubed minus 3x cubed is negative 2x cubed plus x squared plus 7x squared is 8x squared plus 3x, don't have anything to add to that, and then lastly my constant, 7 plus 1 is 8. So it is negative 2x cubed plus 8x squared plus 3x plus 8. I want to show you one more example before I let you try one. And that's because many students find this vertical method so much easier to use than the horizontal method. And you're doing the same process, but it just seems simpler. We're going to align our like terms. So I write my first function down and write the second function directly under it, making sure I line up my like terms. So my 5x squared is going to go in my x squared column. 10x is going to go in my x column, and negative 2 in my constant column. Just notice that all my columns are like terms. Now it's easy to find my like terms and combine them. 6 plus 5 is 11. Negative 3 plus 10 is a positive 7. And 12 minus 2 is a positive 10. 11x squared plus 7x plus 10. So many students find that vertical method easier to use. You can pause the video at this point and give the next question a shot. You can use either the vertical or the horizontal method, whichever one you prefer. When you're ready, restart the video and we can check your answer. See you in a few. Okay, let's see how you did. You can use either the vertical or the horizontal method. I'm just going to use that vertical method, and that's write my first expression or function down, and then the second function, just make sure when I write it underneath that I'm aligning my like terms, except that's a 5. And then add them up. 3 plus 2 is 5. I have 5x squared. 7 minus 19 minus 12x. And negative 3 minus 5 is negative 8. So the solution is 5x squared minus 12x minus 8. I hope you did well here. If not, let me know next time we get together and we'll make sure we do several more examples. We're going to move on now to subtraction. Okay, subtraction works basically the same way as addition. There is one simple change, and don't let it throw you. The first step stays the same. We replace the functions with their expressions. Then we use the distributive property to change all the signs in the second function. Eliminate those parentheses and combine like terms. Why does this work? If you remember way back when you did integers and you'd have 2 minus 3, we all know that's negative 1, but that is the same as 2 plus negative 3. We still get negative 1. The reason that we change the signs when we're subtracting functions is simply it's an easier way to keep track of our signs. Let's go on and look at example 3, our first example in subtraction, and see how this all pans out and how it works. Okay, we first write our functions, replace the function names with the equivalent expressions. Next, we're going to write that other function, the first function, just straight down. We're not going to do anything to it. Here, what we're actually doing is we're using the distributive property, and we're going to take and distribute that -1 throughout the second expression. When we do that, we need to change the sign between the functions from subtraction to addition. So this second function becomes minus 3x minus 8. Be careful that you change the signs all the way across that second function. Many students don't do that, and then they get lost along the way. So you want to make sure you change the signs all the way across. The next step was to write down the functions without the parentheses, then gather my like terms, and then add. I'm going to have negative x. Negative 12 minus 8 is negative 20. So I've got negative x minus 20. Okay, let's do one more example together, and then I'll give you a chance to try it. So I've got c minus d of x, where c of x is 5x squared minus 4x, and d of x is 5x plus 1. Changing the signs in that second function, I just write the first one down, change my subtraction to addition, and then change the signs all the way across, and then write it down without the parentheses, and then gather my like terms, and lastly, make sure I combine all the like terms together. So 5x squared minus 9x minus 1. Now I'm wondering if I can use that vertical method here as well. I'm going to give it a try on this section of the board. So when I used the vertical method before, I wrote the first function down, 5x squared minus 4x. When I write the second function down, lining up my like terms, when I'm doing subtraction, I'm simply going to change the signs as I write it down. So I'm going to look up here at my original, 5x plus 1. So instead of 5x, I'm going to write minus 5x. And instead of plus 1, I'm going to write minus 1. Now I can combine my like terms. 5x squared minus 9x minus 1. So that vertical method works both with addition and subtraction. Please pause the video now and try example 5 on your own. Start it up when you're ready to check your answer. Okay, let's see how you did. Once again, I think I'm going to use that vertical method. That just seems so much easier to me. So I write my first function down, 2k squared plus k minus 3. Then I'm going to write my second function down. Now you have to pay attention to the notation to make sure you've got the functions written in the correct order. Here I've got k minus 1, so instead of a positive k, I'm going to write negative k, and instead of a negative 1, I'm going to change that to positive 1, and now I add them up. I've got 2k squared, k minus k gets eliminated, and negative 3 plus 1 is a negative 2. So we have 2k squared minus 2. Hope you did well with that. If not, please let me know the next time we're together, and we'll do several more examples in class. This is the end of the video, and we're going to continue on in our next video with multiplying functions.